We usually think of numbers as having these fixed, unchanging rules. But the truth is, some numbers have, well, they have secrets. Today, we're going to pull back the curtain on a really elegant and kind of playful insight that's been hiding inside the number 31.
All right, so why 31? Out of all the numbers out there, what makes this one so special? Well, it turns out 31 has this super convenient property that lets us figure out a clever and surprisingly simple way to test if any number is divisible by it. And here it is. This is the secret sauce. It all boils down to the simple fact that 31 is right next door to 30. Now, in a system called modular arithmetic, which you can just think of as clock math, this means that negative 30 is basically the same thing as 1. And this one little idea, well, it's the engine that drives this entire mathematical strategy.
Okay, so that's a cool piece of math trivia, but how do we actually use it? Well, it lets us build this really clever strategy for testing if any huge number is divisible by 31, and we can do it without ever touching long division. I want you to picture this as a kind of number machine. We take a big, messy number and feed it into one side. The machine does one simple little calculation, and out the other side pops a much smaller, friendlier number. And here's the beautiful part. That new little number tells us the exact same thing about divisibility by 31 as the big one did.
So, what are the gears inside this machine? Well, it's actually a super simple process. You take your number and you split it in two. B is just the very last digit, and A is everything else. Then you just calculate A minus 3 times B. If the number you get is still too big, you just repeat the process until you get something really easy to check.
Okay, theory is one thing, but let's get our hands dirty. We're going to run a couple of numbers through our machine right now and see this thing in action. First up, we've got the number 124. It's not too big, not too small. It's a perfect first test for our new strategy. So, is it divisible by 31? Let's find out. Okay, first up, we split the number. For 124, our B, that's the last digit, is 4. And our A, which is just everything else, is 12. Simple enough, right? Now, we just pop those numbers into our formula, A minus 3 times B. So that's going to be 12 minus 3 times 4. And the result of 12 minus 12 is 0. Now, what does 0 mean? Well, since 0 is technically a multiple of any number, including 31, our answer is a big yes. 124 is divisible by 31. And if you grab a calculator, yep, 31 times 4 is exactly 124. It works.
All right, that was a nice, easy one for a warm-up. But what about a number that's a little less obvious? How about 527? Is that a multiple of 31? We just do the same exact process. The last digit, B, is 7. The rest of the number, A, is 52. So we calculate 52 minus 3 times 7.
And 52 minus 21 gives us 31. And, well, is 31 divisible by 31? Yeah, of course it is, which means our original number, 527, has to be 2. See how cool that is? The whole process just boiled a tricky question down to something completely obvious. Okay, so we've seen that it works. It's not magic. But the really fun part, the part that's actually satisfying, is understanding why it works. So let's peek under the hood for a minute. To really get this, we just need a tiny bit of what's called modular arithmetic. And hey, don't let the name scare you. All it is clock math. Seriously, after 12 o'clock, the numbers wrap around back to 1. In our case, we're just using a clock that wraps around at 31. That's all it is. And here is where the magic really happens. Look, any number, let's call it n, can be written as 10a plus b, right? Now watch what happens if we multiply the whole thing by negative 3. We get negative 30a minus 3b. But hang on, remember our big secret from the beginning? On our 31 clock, negative 30 is the exact same thing as 1, so that negative 30a just becomes a. And suddenly we're left with a minus 3b. That's it. That's the whole proof right there. Okay, I know what you might be thinking. Hold on. Can we just go around multiplying things by negative 3? And the answer is yes, we totally can, and here's why. 3 and 31 don't share any factors besides 1. They're what mathematicians call relatively prime. Because of that, multiplying by negative 3 doesn't mess with whether or not the original number is divisible by 31. It's a perfectly legal move, and it's what makes this whole beautiful strategy work. So let's zoom out for a second. What's the bigger picture here? I mean, what's the point of learning this if we all have powerful calculators in our pockets?
And that really gets to the heart of it. This was never about replacing your calculator. It's about something way more fun. It's about the joy of intellectual play, of seeing these hidden connections in math. It's about the deep satisfaction of understanding why something works, not just that it works. And just to round out our little deep dive on the number 31, here are a few other cool tidbits. We already know it's a prime number. That 3 in our rule, well, it isn't random. It comes directly from that cool modular math fact you see on screen. It's also a very special type of prime called a Mersenne prime. And of course, you see it on the calendar all the time. So really, the big takeaway here is that mathematical rules aren't just a set of instructions you have to memorize. They're discoveries. They are insights into the very structure of how numbers work, and when you understand them, you can use them to solve problems in really creative and powerful ways. And that leaves us with one final big question. We just cracked open one small, elegant secret hidden inside the number 31. It just makes you wonder, right? What other incredible secrets? What other amazing patterns are just sitting there in our number system, waiting for a curious mind to find them?